Okay, so welcome to this tutorial, and we're gonna be looking at this question here. So this question reads, approximate the area of a rectangle of dimension. So area of a rectangle of dimension, tell you the, the dimension has been given here, which is just 30 36.02 by 34.97 units. Then they're telling us to use partial derivatives to 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 approximate the area of this dimension. So now, what does this mean first for us? So to approximate the area of this rectangle, so the dimension, so you take note of the dimension, use a different color. The dimension is, so the length, since area is given by uh, length times width, so saying area is just L times b, or breadth or width L by w, just say w like that. So you know that the length is the one which starts first, which is the 36.02, and then my width is going to be 24.97. So they're telling me to approximate the area of this rectangle here. So what can I do? So I, from this here, that area is equal to um, L uh, L by W. This means that I can express the change in area. So change in area, which is just like change in A, because area, change in A as a total differential, dA. So I can express my area in what, in that way, such that I have the formula now to say that the change in area, which is just the dA total differential, now as a total differential, it's going to be partial of what, partial of A with so respect to what, to the length first of all, then multiplying this by what, dl, then I have plus the partial of a with respect to what, w, then multiplying this by what, dw. So this is what I get. So now, what is this partial of a with respect to l, and this partial of a with respect to w? So you can see my a is here, that's my a, so I can find that. So finding that, meaning partial of a, partial of l. So look at my a, I differentiate the l, I remain with what, w there. I do the same, partial of a, partial of w, differentiate there, the w, I just remain with what, with my l. So this is my partial of a, my partial of l, like that. Next, what I need to do here is to identify the best values. The best values, after I identify the best values, I must find the change in dimension. So what do I mean by the best values? So you see that here we have 36.02. It is, it has decimals there, so the best values should not have what, decimal points. So how I identify is, I'm going to round off to the nearest what, the nearest whole number. So now for this one, meaning to have my best value, so I'm going to say let the best value is going to be, I'll call it L naught, round this off to the nearest whole number, I just get 36, like that. Then W, nearest whole number, I see here the 9, uh, I can then add to that, which just gives me what, I can round off to that, which just gives me 25. So these are going to be my what, my best values. So after finding these best values, I can use these best values now to find the change in the dimensions. So these, what I mean is the what, is the DL. So the DL is just the change. This DL is the change in what, in the dimension, which is the change in length. So this is change in length, and this change in length is just going to be equal to the L, the one which have been given in the question, minus the what, the best value. So if I put that there, so I have 36.02 minus my best value, which is just 36, and it's going to be subtracted 2, I get 0.002, like that. Then I go d what, dw, which is just change in what, in w. Then I'll have the best value is going to be w minus w naught, like that. So now getting this here, I'm going to have that I have 24 0.97, then I have minus now. So this minus what? The best value, which is just 25. So the best value, which is 25, when I subtract these two, I'm just going to get that I have a negative 0.03 like that. Then after getting this negative 0.03 like this, so I have the change in the length and have the change in the what, in the width. And after finding the change in the length and width, I can use that to find now the I can use that to find the change in what, in the area, using this formula which I wrote down here at first. So this is going to be, so dA is going to be okay. So what I plug in now, what I found here, I said change. So we had partial of A, partial of W, partial of A with respect to L was just giving us W, and W is just the what, the width. Now the what I use here, I'm going to use, you have to use your best values. So meaning the width we use here is going to be what, a best value, and our best value is just 25. So I plug in here the 25 like that. Then I multiply with what I found to be my DL, which is just 0.02, 0.02 like that. Then I add this plus the change in what, the change in the partial of A with respect towards to W was just giving us L, which is the length. Now the length here we are using is the base value, which is just 36. So I put this here to be 36. Then I multiply by the change in what, in the width, which is just negative 0.03 like that, to find the change in what, in my area first of all. So when I multiply these two here, multiply the 25, so 25 multiplied by 0.02, I get 0.5 here. Then the other one, I have 36 multiplied by 0.03, I get this to be negative 1.08. So I subtract the two and I just get I get this to be negative, so this will be negative 0.58, negative 0.58. Okay, now how do I then approximate my area? I found the change in area, but then I have to what, approximate my what, my area. So I found, so the approximate area, I'll just say A approximate like this. The approximate area is going to be, so now it's going to be what I considered to be the base area, plus the change in what, the change in area. So this is the change in area, the change in area that I found. Then I'm saying my area now, because I had points, which is what I had to say, the 36 and the 20 what, 25. I was at this point, this is where my base was, but then I've changed and I've moved to what, to these points. So this is what I'm saying, that now in order to find the approximate area, meaning we had an area when we were here, then we have now what, we have now moved to these points, meaning the area will be different. Now the fact that I have the change in area, meaning that just adding to this here, the area of this would give me what, would give my approximate area at that point there. So what I do is I find the area, of course using the base values like that. Then I'm saying plus my what, my change in area, that would be my approximate what, area. So what is that going to be? Area is just the length times the width here. So that's the 36 multiplied by the 25, plus my change in area is just negative 0.58 there. So here what do I get? When I multiply 36 by 25, this just gives me 900, then minus the 0.58 there. So minus 0.58, I just get this to be equal to 899.42. 899.42. This is going to be what, unit squared, unit squared. This is what my approximate area is going to be. So now you look at, compare this to the what, to the actual area. So the actual area is just you multiplying its length times width. So the 36.02 multiplied by what, 24.97. So I punch that into my calculator, 36.02 multiplied by 24.97. Then I have that this is just equal to 899.4192. So you see that what our approximate area there, it's really close to what to the actual value. So this is how you use the total differential in order to approximate the area of a rectangle. Well, if you are new, remember to subscribe and we'll see you in the next one.